Here we will understand the protocol layering architecture and the service model it uses in its design principle. So as we know, the internet is complex. There are n number of entities involved in internet, which is making it complex. There are heterogeneous devices. There are different types of links available which are connected. There are different types of routers, switches. So many entities are involved which are making it complex. And there are so many devices which are coming in and going out. So it is highly dynamic. It is not static. It is distributed in nature. It is not centralized. So in a way, it is highly complex in its architecture, in its design principle also. But still, is there a way to actually make a meaning out of this complexity, or to understand it, that how it is designed, how it is properly maintained, how we can understand it as a student of networking? So the answer is yes. It's a resounding yes, because the architecture is layered in principle. So the internet architecture is layered. How it is layered in architecture, and I think it is too obvious also. If anything is complex, we break it down. We break it down into sequence and then try to make meaning out of that breakdown entities, which make it complete as well, but in bits and pieces. We understand it first and then relate it with other entities, and then in a broad way understand the whole architecture. So same way we'll understand the protocol design in terms of its layer standings as well. So we'll start with the TCP IP model. There are 5 layers in operation, starting from the application layer, then down to it as a transport layer, then network layer, data link layer, and physical layer. We have already understood the design principle behind OSI model. There, 7 layers were in operation. But here in this principle design, TCP/IP protocol stack, the layers are 5 in number. So first, I will brief you about the distinction in between OSI model and TCP/IP model. Already once, I think in one of my lecture, I have disclosed it, the TCP/IP was into implementation well before the commencement of OSI model. So it came into existence, TCP/IP model came into existence way back in 70s. And then because already that thing was into operation, already defense organization of US have already implemented it. Those people have already implemented it. So then um, some international communication organization came up with OSI reference model as well. There, the addition of 2 layers were distinct in comparison to TCP/IP model. Those 2 layers were in between application layer and transport layer. Those were presentation layer and session layer. So here, those presentation layer and session layer, we know the work. The work for presentation layer is to format the message received from the application layer, encode it in a proper format. And apart from that, if security is also involved, then encrypt the message. Whereas the session layer task is to maintain the session, establish the session, then maintain it, and then break the sessions. So that is the task of session layer. Obviously, because that is important to do. So TCP/IP model also provide these kind of services, but there is no clear distinction as it is there in OSI model. Application layer and transport layer share this burden. Some of the job which is being performed at the presentation layer being performed at the transport layer, half of the things performed at the application layer, part of the formatting. Likewise, the session establishment and maintenance of the session, all these things being handled at the transport layer in TCP IP model. Though it was already into operation and there was no problem people were facing at that time, so they continued with it, and still we are using the same legacy software TCP IP model, the implemented one. So that is more or less for theoretical purpose OSI model. So we'll understand here the TCP IP model. Before understanding TCP IP model, why they have structured it in terms of layers. And the layering concept is obviously in order to shape a packet from source destination to the source node to the destination node, you require several features, you require several services from your infrastructure. Now, how will you stack it? That is challenging. Where will you implement what? How will you implement comes next, but initially on a broader level, on abstract design, you have to come up with the services which you need to stack in order, that which will come first, and what are all the common services which every other layer requires. So you have to implement it well below all those layers because that service is common. So that is the design principle, that you have to first list down all the services. Then after listing down all the services, you have to stack and pile up those services in such a way that something which is common, which every other layer up requires it, you have to implement it at the bottom layer. Or if so, in this way, people came up with several possibilities, then they zeroed in and finally come up with a TCP IP model. To better understand it, we'll take an analogy in which if suppose someone, a person with name A wants to travel from location A to location B using the airline system. So instead of internet or the network system, here it's a network of airlines. So the people want to use the network of airlines and want to ship himself from a location A to location B. So what are all the options? So we will list down all the possibilities, all the services which he or she do require, and then in the same order we will list it down. First one is that he has to access that airline system. How he will be able to access that system? So he requires some sort of a token, he requires a ticket. So that is, so he will purchase the ticket. So that is the first thing. So booking agent will be there who will provide that service. So he will purchase a ticket. That is a sort of an entry into the airline system. Then he will go ahead, he will go for baggage checking. So that services will be provided by someone. So that is the second layer. Then he will approach the gates there. He will be in queue, so there will be some queue management operation going on there. They will frisk the people, or they will do n number of activities, you know it very well. And then finally you're inside plane after you cross the gates. And then you're inside plane, then the plane operation will start. It will take off through runway, and then afterwards when it is up in the air, then the routing will take place. So here all other airline controllers so will be in constant touch with the plane. They will monitor it, they will route it to the particular destination where it wants to go. And then finally, at the receiving end, at the destination end, the reverse operations will happen. So after finally it has reached the destination, so the landing will take place. So here it was a takeoff, but here its opposite will happen, landing. Then the person will approach at the gate, the reverse operation will happen, then he will claim the baggage, and then finally if he has some grievances, some complaint against, then he will once again approach those peoples and register his or her complaint. So here it's a sort of a peer-to-peer communication. You can see here uh, who was engaging with the person at the very first front, at that front, uh, the ticket vendor. Here also he is interacting with the same person, and their operation of interaction is only through that token or the ticket. So there is a sort of a virtual communication going on at the receiving end, at the sender end, at the destination end. Likewise, baggage also, and gates also, runway landing and takeoff. There is a sort of a virtual communication. It is just for understanding purpose to give you a kind of an analogy or a kind of a feeling that how you can stack the operation, how you can stack the services. So all these services you require at the very front, but here these things have been stacked. What is the importance of stacking these services in layer design? So suppose if you want to change the operation in handling your gates, so when you are handling people, so there you want to onload the people based on their ticket class, or sometime you want to make a change that on a gender basis or on an age basis or on a seat basis, seat numbers basis, you want to manage. So that operation, that services you have to provide, but how you will provide the services, so that is just limited to the gate. It will not impact the baggage check. It will not impact the runway takeoff. So here, if you will make it efficient, it will improve the overall handling time, handling ways, but it has no direct impact on the baggage check and the runway. So this operation, this service is independent, how you will provide it. So there you get a kind of a modularity. If you want to change the operation, it has no impact. Then you don't have to change the entire operation. Suppose when you are interacting with the people at this point, when that vendor will interact, the ticket people will interact with the person, there you want to give certain more services. Here also you want to interact with them differently. So here if you will change the service, it has no impact on all other layers. So that is layer independence, and this independence at the layer, how you will provide the service has no impact on other layers. So this gives you a kind of a modularity which makes the entire system efficient, and you can handle it well. You can understand the problem in your system well. You can understand the system in its entirety. So that's an analogy. Now we'll straightway see. So that's the difference. So you have only 5 layers in case of internet protocol stack or TCP IP model, and whereas in OSI model, these 2 layers are different: presentation and session layer. Presentation layer for presenting and formatting the application message, and session layer for connecting with the destination mode or maintaining the sessions. Whereas both the operations we have merged in these 2 layers. Application layer will maintain most of the work of the presentation layer will be done at the application layer, and the transport layer will handle the session. So here session and transport we have merged into transport. Here application and presentation we have merged in the application layer. Now we'll see the services uh, in relation with the TCP IP model. So what are all the services? At application layer, once again, I'm briefing you about, already I have discussed about all the 7 layers in one of my lectures. So in application layer uh, will come up with a protocol which allow us to access the network. So here we will see network as an infrastructure, and we want to use this infrastructure for running our distributed applications. So suppose at the application layer, we are designing any uh, meeting software. So that application is distributed in nature. So other people are all across the globe and we want to interact with them. So we will look at the internet as infrastructure. We want to use it, we want to access it. So application layer will provide us that access point. So there are several protocols. So whatever the application you come up with, corresponding to that protocol, you will maintain, you will implement at the application layer. So obviously you will implement it in the normal languages, but you will interact with other layer, the down layer, the transport layer, through fixed APIs supported through that language. So there are hypertext transfer protocol, the protocol which at the application will be used for accessing the server pages, the servers, so web pages. So there is a web server somewhere, and the web pages we want to retrieve from that server. So there we will use HTTP for exchanging request and transfer these web pages. HTTP is used. And if you want to make it secure, then we will club HTTP protocol with TLS, though the TLS protocol, initially the name of TLS protocol was SSL protocol, secure socket layer. And now they've changed the name with TLS protocol. TLS protocol works at the transport layer. So clubbing these together, HTTP protocol and TLS protocol, there's a new protocol with name HTTPS, which makes the HTTP protocol secure. So when you will retrieve the messages or the web pages, those will be encrypted and nobody can see them on wire. Then comes the SMTP protocol. This is for simple mail transfer protocol, when you will transfer the mail. So when we have to access the mail server for retrieving our mails, and we have to push the mails and all those things. So for that purpose, we have SMTP protocol. Particularly, it is for pushing the mails from one mail server to another mail server, when, or from one mail client to mail servers, when you have to push the messages, then you use the SMTP protocol for pulling the messages. When as a client, email client, when you have to access or retrieve the messages, then the protocols are different. The protocol name is post office protocol, POP protocol, and there is one more protocol. And now even the facility being provided through HTTP protocol also. We can retrieve the mail server through HTTP protocol as well. So that is about the mail transfer. If we have to transfer file, FTP protocol, so you name the application, there's a protocol for that. So any application you are pondering on, you want to implement, so that implementation will go at the application layer. So anything, any data you will generate at the application layer. So obviously you will generate certain data, and that data you want to share to other node, which will process it, and then your application will run. So that data in terms of network, when in network terminology we'll talk about, that we call as a message at application layer. So that message we are interested in transferring from sender to receiver, and in back and forth we want to communicate. So that is the message. Then comes the transport layer. The job of transport layer is providing process to process communication, or from application to application communication, end to end. these both layers, the implementation of these both layers is only take place at the end nodes, because end nodes wants to communicate. Intermediate node will only take participation for transmitting or rerouting the message. They're not going to process it. They're not going to process it till the application layer, because applications are running on end systems. Applications want to share the messages. So we are generating the message at the application layer, then we are passing on this message to the transport layer. Transport layer will add certain more information in terms of the header file. So what information will it add depends on what kind of services application layer is seeking from the transport layer. If application layer wants transport layer to provide reliable in sequence communication from starting node till the end node, then the header information will be different. Then if application layer requirement in terms of services from the transport layer is normal operation, that they're not seeking any reliable communication, no session establishment, nothing, very primitive information, then the header information will be different. So transport layer will provide two type of services mainly. One is reliable end-to-end communication, another one is unreliable end-to-end communication. So that concerning that service, they will add on certain more information. Once they have added it, then so this is the major operation, this is the major services which being provided at the transport layer to the upper layer, that is application layer. Apart from that, there are more services like error control. So if from location A to location B, when you are sharing the information, location B should know that whatever it has received is correct or not. If there is any error, then once again you have to resend it. So that service is also provided at the transport layer. Next service is flow control. So your both nodes should be in sync in terms of the flow. So if your end node at the destination can process the packet with certain speed, so with that speed only it would be better if sender would send it. So there must be some sort of a mutual agreement in between sender and receiver, that is called the flow control. And there are several other services. Based on the services, if you will keep on adding the services, your header information will increase, your header size will increase. And that is also one of the concern if you are not onto the network which is providing higher bandwidth to you. So, and it depends on the service also, what kind of services what kind of application you are using at the application layer. That all later on, I think once we will approach one by one all these layers in detail, it would be better to discuss those things. Anything which comes from the application layer will term as message. Once the message being received at the transport layer break down the message, because it has to use the packet switched network. So down to the transport layer, it is going to use in terms of network core packet switched network. So it will break down that entire message into different chunks, and then it will add on the information which it do require for providing connection oriented or connectionless, whatever kind of service it is providing to the application layer. So whatever comes out of that, after that addition, there is a message, it has break it down into different chunks. It has taken all the chunks one by one and added the information, right information, control information in terms of header. So that header plus that message chunk is called segment. So there are two parts on each and every layer. One is called the data part, that we call that what we have received from the upper layer, that we also called as payload. And another one is a control information that we call as a header, or in some cases we add trailers also. So there's a payload. Payload is what we have received from the upper layer entirely. So payload also include the control information, but control information of upper layer. The lower layer will not touch that control information. For lower layer, that is one data itself. So lower layer will add its own control information, then it will create one segment here, then it will pass it on to the network layer. At the network layer is also providing certain services to the transport layer, and transport layer is seeking what service? Transport layer now wants to find a path from source to destination. So there must be some layer which will do that on behalf of transport layer. So network layer is that protocol. So here we require to find out the addresses. So IP addressing will take care of that, and the protocol name is IP protocol that require IP addressing. And once you have given the addresses on the entire network, then the routing algorithm will come into operation. Those routing algorithm will find out a path from source to destination. Every intermediate node will maintain this based on the destination, that where it has to forward. All those things, routing algorithm in detail we will understand, but here in nutshell, routing algorithm will provide some kind of information and put it on to all the routers, and then routers job is to interact with the packets. Once it has received a packet, it will process it, figure out its destination address, based on the destination reroute it so that it can finally reach the destination. Once it is over, so to do all that, it at the network layer you do require certain control information, and particularly the main control information is source and destination address in terms of IP address. That is also called logical address, because that address can change. If you will change from one network, or node is there in one network and you will go to another network, then you will be assigned the different IP addresses. So that is called the logical address, IP addressing and IP addresses. And the network layer job is to route the packet, and network layer do require to add certain control information. So it will take the payload from transport layer, that is nothing but a segment, and then add certain more information in terms of header, and then header plus payload. The network layer is called datagram or packet. You can call it packet as well as datagram, network packet or datagram. So there's a distinction. We can't interchangeably use the word message, segment. So here onwards, whenever we'll mention any particular word that is associated with a layer, so you should be able to correlate with. Whenever I'm using the word message, that means application has generated it. Whenever I'm using the word segment, that means it has relationship with transport layer. Network layer, it is a packet or datagram. So once it is over, then it will pass it on to link layer. uh, Link layer, what link layer will do? Obviously from starting to end there is not a single link, intermediate nodes do exist. So obviously on an abstract level, our idea is that there must be a transfer of that packet from source to destination, but that will happen. In technical terms, I want to use end-to-end connectivity. But to ensure end-to-end connectivity, intermediate nodes do exist in between. So there must be hop-to-hop connectivity. So first node, sender node should connect with first intermediate node should connect with second intermediate, third intermediate, fourth intermediate, nth intermediate, and that nth intermediate node finally conclude the transmission and reaches to the destination. So there are in between n number of intermediate nodes. So there are several hop to hop transmissions required for ensuring end-to-end connectivity. So who will ensure it? Link layer will ensure it. Link layer will ensure that from one over the one link, transmission will be possible from one hop to the next hop, and then from the next hop to the next hop, from next hop to the next hop. So link layer is at the second layer. So obviously when you are transmitting it, you are routing it at the link layer, you do require addressing here. Here the address is physical address or the Ethernet address or the MAC address, which is nothing but the 48-bit hardware address. It's a hard-coded address, and all NIC cards, network interface cards, have this address, and that is unique. So link layer transmit or reroute the packet based on this MAC address. on a single network and over all other networks. So in nutshell, you can say that to ensure end-to-end connectivity, intermediate hop-to-hop connectivity is also required, and link layer takes care of that. There are two types of layer here because that links are shared among several entities, several nodes. So one, before sending your data over the link, one has to access the link. So to access the link, there is a medium access control protocol. So that is one protocol. Second protocol is that certain control information you do need to write, because uh, for physical addressing part, or so that is called framing of frame. So when you have taken a network packet or a datagram as a payload, so you will add certain control information here. Control, it is exclusive layer where not only you will add header fields, you also add certain trailer fields. So along with payload which you have received from the network layer, header you have added and trailer you have added, that complete thing is called frame. That framing, that framing depends on the technology, the medium which you are using. If you are using Wi-Fi, that framing will be different. If you are using copper wire, framing will be different. If you are that is called framing encapsulation. So depending on the media technology which you are using for sending your packets over that link, the framing concept will change. So you might have heard about the ATM relay network. So those are all the Ethernet technology, then Wi-Fi technology, there's several more also. um, so based on the technology, that frame formulation and frame encapsulation happens. So, and that is taken care at the link layer, and that layer which specifically caters with these requirement of encapsulating frame is called logical link control layer. So link layer has two divisions: MAC layer, which is near to the network layer, and LLC layer, which is near to the physical layer. Then comes the physical layer, and the physical layer job is purely hardware based. It will convert those bits which are the part of frame into the electromagnetic signals, and then push it on over the wire. And how you will do the wire encoding, and what will be the rate of sending, all these things will be decided at the physical layer, and that is all in hardware. So what is there in hardware and what is there in software? So just let me conclude with this. Physical layer and link layer, these two layers are entirely in hardware, so, or firmware. So NIC card, which is there with our systems, which is there in our network devices. So that network interface card is nothing but the implementation of link layer and physical layer. So obviously the Ethernet card you can't use as a Wi-Fi card because there's a technology difference. So if so based on the technology which you are using, your interface card should support that. So link layer and physical layer gets its implementation through network interface card. Then this network layer. So network layer is nothing but, you might have heard about the routers. So there the router, both it requires a hardware for interfacing with several links. So its implementation is both in hardware and software, because software you do require because it need to be smart. So that routing algorithm and all those algorithms, where those things will run, how will you process the packets. So everything happens at the network layer. So there you require both software and hardware. And why even at link layer and physical layer you need to be software based, and means hardware based, because here you want fast operations. So hardware is the best approach to make it fast. And here at the link layer we do the error control, flow control, all those things happen. So if you will do it using software, then it will take more time, and here the time is the constraint. We want to minimize that delay, we want to reduce that time. So that's why most of the implementation is in hardware. Though here they also use some firmwares on that card, but that is minimum. The network layer is both in hardware and software, and these two layers, application layer and transport layer, are entirely in software. And whenever we install any operating system, along with operating system, it all comes. The TCP IP stack module comes along with it. So every operating system designer has to implement application layer and transport layer, and sometimes parts of network layer also. So that comes along with the operating system. OSI model already I have discussed. Then comes the encapsulation, though I have disclosed it in terms of that payload concept once again. So this is the application layer. So from this device, we want to interact with this device, the source device, destination device. So there are certain operations which you want to implement on the end nodes. So that services which you will implement at the end node is called end-to-end arguments. And there is also one catch. When you design any network protocol stack, what will you implement on the edges? How will you decide that? Initially, when this TCP IP model came into existence, at that time, those end systems were strong in terms of computation. The computation power was more in comparison to switches, and the core infrastructure, hardwares, routers, switches, those things were not so computational, means their computational power, that computing power was not that much. So they thought that those things which require more processing power, so it's better to keep them up the stack, so that only source node and the end node has to execute those things. So whereas if you suppose uh, this flow control, there is a concept of error control and flow control at the transport layer. If we could have implemented it at the network layer or at the link layer, so that then all the intermediate nodes have to process it, have to execute that code, and it requires more time, more processing time. And at that time, those switches and routers were not that much capable. So that was also one consideration which goes into the design. And they thought that something which require more computational power, it's better to keep those things up the stack, either at the application layer or at the transport layer, so that only source node and the destination node has to execute it. But now that is not the scenario. That's why there are certain tweaks which people have started implementing, because the routers and the switches are now much more capable. That's why you must have seen software defined networks. So there the tweak is only in terms of providing services at which layer, where will you provide the services. Even the computational intensive services can you provide at the network layer for improving the efficiency, for improving the reliability. So there are several things goes into it. And then there is a whole domain, software defined networks and all. So that is not our part of study. But here I want you to understand the concept behind end-to-end argument, what goes into that, which leads to the implementation of certain services restricted only to the end-to-end. So only the source node and the destination node will do it. So anything at that time which was taken as a computational intensive job uh, were implemented on end side. And something in the core, very trivial but important things, because routing was important. So they keep the IP protocol, that the network protocol, uh, less computational intensive, so that at least there will be a connectivity. So that is one important thing. So here we have generated a message at the source node. We have generated a message M. Now after generating a message M, transport layer will add some header information. So this is called encapsulation. When transport layer will receive a message M, it will not look into message M. It will add certain information. So it will consider it as a black box. It will just take this, add control information, HT. That control information is in relationship of the services which transport layer is going to provide to application layer. And once everything is all done, all set, it is encapsulated message M along with HT, then it is called segment. Once the segment is already there, you will pass it on to the network layer. Network layer will provide certain other header information. So it will add those header information based on the requirement, and then it will encapsulate everything nicely, and that is called datagram or packet. So it is not only datagram, it is also considered as a packet. And then it will pass it on to the link layer. Link layer, based on the technology, make a frame out of that. It will consider everything HL. It also add trailer, though they have added just one header field here, link layer, but not only it will add header, along with header it will add certain trailer means some extra bit after that datagram also. And then the link layer will do uh, its job, and the job is to convert that bits into signals and then pass it on, propagate it on. At the link layer switch only operates till the link layer, because its job is to figure out the link address, the Ethernet address, MAC address, and where that thing is written. That thing has been written on the link layer, so it will go till the link layer. It will figure out what is the destination MAC address. Based on the destination MAC address, once again it will recreate the frame. So here you can see here you can see it will de-encapsulate the packet. So whatever it has received at this interface, it will start de-encapsulating it. After de-encapsulation till the physical layer, it will figure out that okay, this is the destination MAC address. Based on the destination MAC address, because the destination MAC address correspond to this router, once again it will recreate it. Once again it will recreate the frame. Once again it will pass it on to the physical layer. Physical layer will do the same operation again. It will once again create the electromagnetic signals. Those electromagnetic signals will reach at this router. Now the job of the router is to figure out what is the IP address. So to where is IP address is written? IP address is written at the network layer. So it has to de-encapsulate the packet till the network layer. How it will do? So it's a sort of an onion. So so onion model also you can see, because the onion wraps, you have to unwrap again and again, and once again you have to wrap it up. So here at the router you will go till the network layer. So physical layer till the you will create the link, means at the link layer frame you will recreate. After recreating the frame, you will de-encapsulate it. After de-encapsulation, you will pass it on the concerned information to the network layer. After network layer receive the datagram, then it will once again figure out what is the destination IP address. After finding the destination IP address, it knows that it is directly connected, so that it can pass it on directly to it. So that once again it will recreate the header, it will create the frame again, it will pass it on to the physical layer. Then this physical layer will pass the bits in in terms of electromagnetic signals. Once it has received here, then this node figure out that I am the destination. So obviously application is running on my destination, and that application data it requires. So where is the application data? Is the application data is at the application layer, so it has to re-encapsulate it till the application layer. So that is the overall concept, and that's what throughout the course we have to understand, that how and where the implementation of protocol happens, what goes into the protocol, what is the structure of the protocol, how protocols work, how they share the message, what is the format of the message, and that's all.